So we were just looking at a couple of standard ways that people deal with sound transmission from one room to another through some sort of wall assembly. And the typical issues are openings, right? So that's why we use sealant. We don't want to have little cracks in the air to be able to get through, or don't line up the outlets and things like that. And then another issue is the massiveness of the materials, the ability for insulation inside the walls to absorb some of the vibrations, to kind of help slow down that sound as it's moving through. And then the massiveness of the drywall on either side and the size of that cavity in between. That all of those are sort of the standard ways that we start to think about this. Well, another approach is using a resilient channel. With the resilient channel, the concept is that we're going to take head-on the issue of the vibration. So instead of having a series of layers of drywall attached directly to various studs, instead of doing that, where we're nailing it right through, if we're nailing it right through and these things are all directly connected with each other, well then clearly when one starts to vibrate because of the sound waves coming at it, it's going to vibrate through each of those materials and then vibrate out the other side. Now, some of the sound will be lost in each of the transitional moments of vibration, and there are various ways that we can sort of deaden that, like we've said. We can expand the space, we can do little bits of sealant, there's lots of different things that we can do, but the issue is still there. We still have this continuity of one element to the next so that the vibration has the ability to find its way all the way through that wall assembly. So the resilient channel says, well, what if we did instead, there's our stud, and maybe on one side we've got the normal drywall happening, but on the other side we add another layer, and that layer has a little bit of flexibility to it. And so at a regular interval, we have these resilient channels that get attached to the studs, and then the drywall gets attached to the resilient channel. So the version that I just showed is one that's often referred to as a Z channel, and there's certain advantages to the Z channel and certain disadvantages to the Z channel, but some folks really like them. And so then here's the stud, and that resilient channel is tied directly into that stud, and then when the drywall is out over here, it's going to be able to vibrate just a little bit. So if we think about it, because of the nature of how this shape works, if you kind of imagine that metal can bend just a little bit at each of those different creases, so you could imagine it going kind of like that, or possibly even going kind of like that. So it can kind of waver in between those various spots. Now, I've exaggerated it here in order to kind of make the point. The idea is, as the sound waves are coming and they're shaking those drywall layers are then shaking the resilient channel, but the resilient channel has this ability to kind of give a little bit. And so you don't get that direct relationship of the vibration from the drywall getting right into the stud, then getting right to the other drywall on the other side, and then reverberating out into the other space. So instead, there's this little deadening spot that can absorb some of that vibration. And since sound is essentially vibration, this is one of the sort of key ways of being able to kind of deaden the sound. So the one example we just showed is that, that kind of Z channel. Another shape you'll often see will be something like similar to a hat channel, which means it kind of comes down and then it does just a little element there, and the stud is there, it's still attached into the stud, but then this thing can, just like that Z channel, have a little bit of flexibility in it. And this little bit, when you're pressing up against the drywall, you can sort of push against it and it'll give a little bit of support, but without being attached at that other end. And so it has still that little bit of give. So this is a system that a lot of builders actually prefer. There's advantages and disadvantages to both, but the idea is that there's this little bit of give in these various systems that allow for that vibration to get taken up. Now, one of the things that happens all the time with this, which is why I've actually never really trusted resilient channels very much, is that you'll get the builders and they'll come out and they'll be the stud, and you'll tell them that you want to use these resilient channels, and so they'll put those in nice and sturdily, and then they'll put the layer of drywall on and they'll screw that right in, and they'll screw it right in straight through both the resilient channel and into the stud. And the reason they do that is they actually don't like that little bit of vibration. The drywallers, when they're putting that stuff up, it feels wrong, right? It doesn't feel like they're making a solid wall. Now, you actually have to really be touching it to feel any vibration at all. The vibrations that we're really talking about are at a very micro scale. Like, it's not something you can really feel easily, but it does give it just a little bit of give, and that little bit of give will sometimes make clients think, well, our drywall is not very good. They don't seem to be able to attach the drywall very well. And so the drywallers often feel like they need to get things to be attached more securely, and so they'll screw right on through into the stud, which means that effectively that resilient channel is completely useless. You've just made an extra step, an extra expense for zero reason, because now it's the same thing as having the drywall connected directly to the stud. So if you're going to do it, you have to make sure that everybody truly understands and is appreciative of the point of doing it, and making sure that when they're making that connection, they're not doing it in a way that's going to short circuit that vibration protection. So the drywall gets attached just to the resilient channel, and the resilient channel gets attached to the stud. And that way they have that little bit of vibration that's available in there. So this is one of those ways, that idea of the resilient channel, along with all those other issues about the gap size, the solidity of the material, the trying to plug all the holes, making sure you're not lining up the outlets, switches, things like that. The other issues like undercuts on doors, all of those things. It's a whole bunch of issues that you're going to be sort of working with in order to stop the sound transmitting from one side to another. Like I said before, the only real way to do this is to actually have these be two completely separate structures. That's about the only way to stop transmission of sound completely. So you're looking at sort of the best chance you can to reduce a certain percentage. But even if you can only reduce, say, 10 or 20%, that actually is potentially enough to make a difference in people's lives, so that they actually feel comfortable sleeping or living or working or whatever it is in those adjacent spaces, to just get it down enough. So we're not dealing with the ability to like wipe away any sounds transmitting through here. If that's what we really need to do, then we have to go way out of our way and create fully separated structures. So that's not very typical, so you're not likely to see that too much, and I don't imagine they would ask you that on the exam, but they are quite likely to ask you what are some of the ways that you could mitigate sound transmitting from one room to another. So just remember what you're trying to stop openings, because the sound will find those openings. You're trying to stop vibrations, and you're trying to give something that can kind of absorb the sounds as it's moving through.